children, welcome back to EDUHUNT classes. In the previous video we watched regarding mains model worksheet 4 and this particular video we are going to solve regarding mains model worksheet 4A, okay, some advanced level, okay. Now here we have questions regarding the particular mains model. We'll see what is that one we will solve already, okay. So first one, the question is all about the statement type questions. What is that? Statement type questions. So statement A and statement B is given. We will have to read it out and clarify the particular statement right or wrong. Okay. So first one is statement A. NaOH is highly corrosive in nature. What is NaOH? NaOH is named as what? Sodium hydroxide. We know sodium hydroxide is a strong base and also it is having that corrosive in nature. Okay, this is not safe that of. So laboratory sodium hydroxides are not that safe because it is having corrosive in nature. So statement is absolutely true. Sodium hydroxide is generally highly corrosive in nature. Now statement B. It blisters the skin by combining with the oils and fats of the skin. Yes. Children, our skin do contain some oils and fats, right? So if that particular base NaOH falls on the skin, it gives some painful blisters. Chin chin bubble vachestai. Okay, that is corrosive action going on. This statement is also true. So A and B both statements are correct because why? NaOH is highly corrosive in nature and also it blisters the skin, the combining with the oils and fats of that particular skin. Okay, both statement A and B are absolutely true. So the option C is correct. Okay children, yes, okay, fine. Now moving to next question. Okay, which of the following statements is or incorrect? Which one is false? They are asking us. Okay, now read all the questions, all given options A, B, C, D carefully. Okay, alkalis liberate nitrogen from ammonium salts. Is it right? No, because nitrogen is not liberated. What is the equation? What is the equation for that particular thing? Alkalis liberate nitrogen from ammonium salts. Where do you see this particular property? Did you see this in general properties of soluble ester alkalis? In that I told you the fifth general property regarding action with ammonium salts. I told you, no? In that I have written like this, where when we take ammonium salts, okay, when we intake ammonium salts and to that if I add any base content alkali, what do I get children? I get metal salt plus water plus which gas? Which gas? Ammonia gas, yes, NH3. I told you, no, in that particular topic in that video I told you, which is that general properties of soluble bases or alkalis. In that I told you we have taste, touch, effect of indicators, and after that action with acids, and the last one is action with ammonium salts. In that particular concept I gave this example also, reaction sodium hydroxide, where you can observe the liberation of ammonia if you add ammonium salts with that of an alkali to liberate which gas? Ammonia gas, but not about nitrogen gas. So this particular statement is definitely wrong. They are asking us incorrect. No, we have to take this because it is not liberating nitrogen, it is liberating only ammonia gas. Okay. Given B, C, D also will check right or wrong. Insoluble hydroxides decompose on heating. Yes, children. The insoluble hydroxides are the precipitated downward arrow mark things. You know what happens if you allow them to heat? They will decompose happily. Okay. This is right. Okay. So not enough doing any marking because they asked us incorrect. No, we have only A. Okay. Now alkalis absorb carbon dioxide from the air. Children, yes, alkalis do absorb the moisture in the atmosphere, right, such as carbon dioxide from the air. Okay, yes, the alkalis, the soluble bases. Okay, now this is also correct, C is also correct. Now D, alkalis neutralize acids to form salt and water. Yes, the neutralization reaction. Okay, so here the option A is wrong. Okay, that's the reason we have chose the option A bit. Clear, no, the equation? Where do you observe this? In the action with ammonium salts. Which action? Whose action is that? Action of alkalis. Action of alkalis with ammonium salts. There you'll observe all that. Okay. In that particular video, you'll observe this equation example. Okay. Which gas is that? Ammonia gas, NH3, but not about nitrogen gas. Nitrogen is symbol N2. Okay. Now moving to next question. Question number 3, children. Here we go. Which of the following metallic salt gives an insoluble hydroxyl alkali solution? Okay. So they're asking us insoluble hydroxide. This is from the general properties of bases. So if you observe NaCl, KCl and CaCl2, these three are happily soluble hydroxides. Whereas FeCl2 is an insoluble hydroxide. How we will see? There is an equation for that. I'll write you here. When I intake FeCl3 and to that if I add sodium hydroxide, 3 molecules of sodium hydroxide, I do get FeOH thrice and leftover one is 3 NaCl. In this particular equation, we observe the particular activity, in the PPT section I told you. This is having downward arrow mark, which means it is a insoluble, which means it is a precipitate. I told you, insoluble hydroxide. This is the one. Okay. FeOH thrice. It is a insoluble hydroxide. And what is the particular given example? Given one. FeCl3. If you add FeCl3 to that particular alkali solution of NaOH or any other, we do get an insoluble hydroxide and also with that particular salt. Okay. The given option FeCl3 is matching with that of insoluble hydroxide. This is the equation for you. Okay. Clear now? Okay. Moving to the next bit. Okay. Why NaOH is not used for preparing standard solution in the laboratory? NaOH, the soluble base, strong base, what is that? Sodium hydroxide is not prepared standard solution in the laboratory. Why, Because I told you that nature also in the particular previous videos. Given options are, since it is a strong base, okay, since it is highly deliquescent in nature, third, since it's slippery to touch, and 4, all the above. What according to you it is the correct option? How many of you chose sincerely D? Who are those people, children, chose all the above option? Raise your hands. Is it true? Do you think slippery touch is something not standard one and so strong base? These are some confusion. These statements are right, the given options are right, but not according to the question, children. Okay. Slippery to touch, strong base, that is not an exact answer for that, and the exact answer is B, which is it is having a deliquescence in nature. What deliquescence? Nothing but it absorbs moisture from the atmosphere. Absorbs moisture from the atmosphere. Okay. For that reason, we will not make standard solutions of ammonium hydroxide in the laboratories. Okay, because it absorbs this particular carbon dioxide from water. Sorry, from air. Before bit, you all know. Where is it? I'll show you. Here, question number 2, we have this, alkalis absorb carbon dioxide from air. This is the explanation for that, because it is absorbing moisture from the atmosphere, such as carbon is from the air. It is having deliquescence in nature. So that's the reason we will not prepare standard solution in the laboratory of this particular NaOH. Okay, clear now? The option is B, since it is a highly deliquescence in nature. What deliquescence? It is absorbing moisture from the atmosphere, which is absorbing carbon dioxide from the atmosphere. It turns into some liquid solution, children. That's the reason it dissolves now happily. That's the reason we will not prepare standard one, because the weight may vary. Okay, the calculation will be different. We will not prepare such things in the laboratory. Okay. And moving to next question, question number 5. Highly active metals dissolved in water gives dash gas. in the formations of the respective basic oxides. Okay, children, for this we also have an equation regarding if we take highly active metals such as sodium, to this if I add where is this water, yes, if I dissolve this in water, I do get respective basic oxide such as what is here, NaOH, plus which gas they are asking us. Now I wrote the equation for you, you have to find it out. Okay, find out. If I intake 2 Na plus 2 H2O gives rise to 2 NaOH plus what? Come on, balance it. 2 Na, 2 Na, okay. Now here O is 2, so I got O as 2, okay. H is 2, I got H. Here 4, 2 2s are 4, no? What left over 1? Left over 1 is which gas? H2. What is that? H2, okay. I'll write it again. H2, okay. Which gas is that? H2. Fine. The given blank, it is hydrogen gas, option B, H2. Clear? This is all about the fifth bit. When we react the high active metal with that of water, dissolving in water, it gives the basic respective oxide and also with the hydrogen gas. Okay. Now, moving to question number 6. After the completion of neutralization, the color of litmus turns. Children, neutral solution doesn't give any change in the color. Okay. If it is an acid, I'll write it for you. Wait. If it is an acid, it changes what? Blue litmus paper to red color. Yes or no? Yes or no? Yes, it changes from blue to red. Okay. And if it is a base, it changes from red litmus paper into which color? Very good, blue. Because B for base and B for blue. I told you, no? Easy identification, okay? But here they are asking us to identify after the completion of neutralization, the color of litmus paper changes into. Do they give any acid or base? No. So, red to blue, not required. Red to colorless, not required. Blue red, not required. What is the change? Do you observe any change in the color? No, there is no change at all because it is neutralization, no? In the sense neutral. There will be no change at the completion of neutralization. There is no such change in the colors of litmus paper turning. Okay. These are the 6th bit. Question is 6 and answer is no change, that is option C. Okay. Clear now? Now moving to next question. Yes, the last question in the particular mains model worksheet 4A, and this is something tricky. You have to observe clearly and do the particular process. Okay. 7th bit, the something flowchart is given for you to identify the particular A, B, C, D, E, F, G, just A, B, C, D, E, F, G, H, I, J, O is also given. Okay. We'll find out what is that. Okay. Yeah. First of all, give the information in particular bit, the question, and then read out all of that. Okay. A is an orange color dichromate which swells on heating. Okay. Children, A is something, an orange color dichromate which swells on heating. So they gave here A plus B. Did you see this equation? I'll show you. Okay. Here, if you observe the particular bit, here. Okay. Is it okay for you children now? Yes? Okay. Children, here they gave, look carefully, A upon heating, triangle means heating, it giving rise to B, which is having upward arrow mark in the sense, it is a, tell me, if it is having upward arrow mark, what it is called as? It is a gas. So, B is a gas, and A upon heating, triangle means heating, Okay, heating. It giving rise to A giving rise to B, C and D, and B plus E giving rise to F. So these three B, E, F and gases. Okay, the reaction goes like this it seems, and this is upward arrow mark like this. And this is all about the equation arrow mark, but not about the gas and reactants products, reversible, not that. Okay, this is showing the arrow mark in the direction showing us. Okay, so next comes this F plus G gives rise to H. Okay, and here from the reverse, H plus I gives rise to J plus D. Oh, and also H and also F. Okay, should it's something you have to understand regarding this. See, first the equation like this: A gives rise to B plus C plus D, and next B plus E gives rise to F, and after that F plus G gives rise to H. After that H plus I gives rise to J plus D plus F. The equation is like this. Did you observe this? Arrow mark up to F. It is also including. Okay. So this is all about the particular question for you. I'll minimize again. Okay. Yes. So to understand the question, I just showed you in detail with the making it maximize. So still more the question is hidden. Yeah. Okay. I'll arrange it. Just a second, children. Okay. Okay. Can you see now? Yes. Children, listen. So this particular equation, the particular flow chart is talking with us with the particular given information. Okay, let's see what is that. A is an orange colored dichromate which swells on heating. So we have an equation, yes, what is that? A plus, I'll add the equation here. A upon heating gives rise to B, which is a gas, plus C plus D. We have to identify what is all that. They gave in the information in the particular question that A is an orange color dichromate which swells upon heating. Heating at all this symbol, no? Delta, triangle symbol is heating. Yes. So we have to find out what is A. A is something, a dichromate, it's in children. Dichromate in the sense, the formula of dichromate is Cr2O7. Okay. And that it is in orange in color. Children, the orange color dichromate in the laboratory is nothing but ammonium dichromate. What is that? Ammonium. Repeat after me. Ammonium dichromate. Okay. So this upon heating gives rise to the gas such as nitrogen gas N2, which is gaseous form, upward arrow mark, and also we have okay, we'll see what is that. C is a green colored compound. So C is nothing but a green color compound. So from this if we liberate C will be chromium oxide, which is having green colored compound. Okay, chromium Cr2O3. It is a green color compound, children. C is a green colored compound. And we have D, anything here? No. Okay. See, A giving rise to B plus C plus D upon heating. So A is nothing but an ammonium dichromate, NH4Cr2O7. And for this we are indicating with the B as a gas. No, so definitely it will be a nitrogen gas because we have nitrogen gas. And after that we have a green colored compound, that is chromium oxide. And to that we are giving D. D is leftover one is water, H2O. Okay, it gives us N2 plus Cr2O3 plus 4 molecules of water. Okay, so from this equation we can say that the given A will be NH4Cr2O7. Okay, and what we got B, children? B as nitrogen gas. Okay, I'll write here B, nitrogen gas. Okay, and C what is that? Cr2O3. Okay, and D is, yeah, H2O. So from the previous things we got all these things, double coming, okay, O3. Okay, here we have the particular ABCD from the first reaction. Okay, we got this A giving rise to B plus C plus D. A is a orange color dichromate, this since it is a ammonium dichromate giving rise to nitrogen gas, chromium oxide and water. Okay, I'll have the names for you. Should I? Yes. Names of this, it is ammonium dichromate. Okay, this is nitrogen gas. Okay, children, and this is chromium 3 oxide, and water molecule, you know, H2O, right? Yes, water. Okay, so next is we have page number. What is that? If you can observe the page number, particular one, just a second. The page number is 23. There you can observe the particular flow chart, children. Okay, and here it is. Okay, so this is all about A, B, C and D. Something is missing, H2, 8. Children, H2, H, hydrogen 2 and 4, 8, no? Oh, I missed here writing 2. Just a second, I'll write here. Okay. NH4 twice, Cr2O7. So balanced, no? N2, yes, N2, Cr2O7, everything is balanced. Okay. So NH4 twice. Okay. This is all about ABCD in the first particular equation. And after that, if you observe, B plus C giving rise to F. Where should I write that one? I'll write it here. Okay, this one, this particular reaction, B plus, here, B gaseous plus E gaseous giving rise to F, it is also gaseous form. Okay, what is B over here? We got, what is B? From the previous equation, we got B as nitrogen gas, which is N2. And to this, we have to find out what is E and F. Okay, nitrogen gas, no, upward arrow mark, which is the gas. I write here. Upward arrow mark in the sense it is a gas, and triangle delta we called as it is a upon heating. Okay, clear, no? Yes. So we have your A and C we find. Now E. E is a gas which puts off a burning splinter with a pop sound. Okay, children, there is a special gas that, you know, puts off ante elugutunna burning splinter ni candle gani matchstick aggi gani, it puts off, in the sense it is offing the particular light. Okay, and it is giving a pop sound. Pop sound is something a pop sound will give. That is nothing but definitely it is hydrogen gas. Okay, hydrogen gas is having that ability to put off the burning splinter with which sound? Which sound? Pop sound. Okay, that is so easy to identify. So pop sound is nothing but it is the which gas? E, no? E is, okay, E is hydrogen gas. Gas again, so upward arrow mark. So what do we get if I add N2 plus H2, what do I get, children? I get ammonia, NH3, because it is also a gaseous, right? Because it's telling B upward plus E upward gives F upward. These three are gases, so nitrogen plus E puts off burning with pop sound is hydrogen gas. So if I intake nitrogen plus hydrogen gases, I get the product is definitely a ammonia. Okay, so ammonia is also gas. So to balance this, N2, so I'll write 2 over here, 2 over here, and H and okay, H2 with 3 is 6. So here I'll write 3. Okay, this is all about the second equation. B plus E giving rise to F. So we'll write the names. Okay, now we'll write the names also for that. So what is given? E and F is given, no? Okay, E and F also we found it. What is E and F? E is H2 E is also gas, no? F is also gas, yes, okay. F is ammonia, very good. Names for this: hydrogen gas and ammonia gas. Ammonia gas, okay. This is all about A, B, C, D, E and F. And we have others. What is that? G, H and I, J. We have to do that also. Ammonia, I. Okay. And okay, we got this side and this side, and now we have to find this F plus G giving rise to H. Okay, where do I write? I'll again minimize this. It goes, maybe no, okay. Okay, no need. We'll just do with this only. Okay, I'll let it here then. Place sufficient, no? Okay. So here it is written that, okay, here I'll write it here for you. Okay, and here what is there? F plus G. F is a gas, so F plus G giving rise to H. Okay, we have this equation also. So we have E also be solved. Yes. Okay, done. So now coming H. H is white dense fumes, it seems. White dense fumes with that of F, because F is NH3. From the previous equation, if we take NH3 here, NH3, no need of 2 children, because that is generally a balancing one. The previous one, what did I write? I wrote here F is NH3, no, that's the name I've written here. No need of 2, no need of borrow 2 this, okay? Yes. So if I take ammonia with that particular of something G, it seems, and that is having H, which is having white dense fumes. Children, white dense fumes containing one is nothing but NH4Cl, children. Ammonium chloride do contain white dense fumes. What is that? Ammonium hydroxide, sorry, ammonium chloride contains white dense fumes. So what is the required G now? NH3, what is left over? HCl, hydrochloric acid. So we do get white dense fume, that is nothing but it is a NH4Cl, ammonium chloride. Very good. I'll write the names also. Okay, place not sufficient. What is the given one, children? G is given and also H is also, we found it. G is nothing but, what is G? G is nothing but, what is that? HCl, very good. G is nothing but HCl. Where is this? Oh, okay. HCl, and H is having white dense fume, that is nothing but ammonium chloride. Ammonium chloride. What is HCl named? Hydrochloric acid, and this is ammonium chloride. Okay, ammonium chloride. Yes, yes. We have here G and H. What is this extra one came? Okay, I'll delete this. Wait. Okay. So we have here G and H, HCl and NH4Cl. Okay. So this side is also done. This side is also done. Sorry. This side is done. This is done. This is done. Now the last one. H plus I giving rise to J plus D. Okay, I'll write here. H plus I giving rise to J plus D. What else is there? H plus I giving rise to J plus D plus, oh, F is also there, no? Plus F, which is having upward arrow moving, since it is a gas, okay? So from the previous things, what do we get? We got all this names. I'll see. We got F as NH3, F as NH3, and next D as H2O. Very good. D as H2O. NH3 is gaseous now. upward arrow mark. And what else we got? Did we get G? G is not given here. Okay. Did we get H? Yes, H is NH4Cl, no? NH4Cl plus we don't know what is I and what is J. We have to find out what is this. So NH4Cl giving rise to H2O plus NH3. Something we have to write over here. We'll see what is that hint from the previous equation. Okay. Here the saying is I turns milky on passing CO2 through it. See, there is a I which turns milky. Since milky means tellaga palga tayaraipotayi. Okay, it turns like that solution and passing with carbon dioxide through it, CO2. So that I which turns the milky, which turns into milky when we pass carbon dioxide gas into it is called as calcium hydroxide. What is that, children? It is named as calcium hydroxide. That is named as calcium hydroxide. Okay, so that we got here as the equation, and you have to find out G also. Know what is J or J? Sorry, not G. Sorry, J. We have NH4Cl, COH twice, and we got H2O plus NH3. What is the remaining one? CaCl is left over. No, yeah, CaCl2. Ca and Cl. Okay, the balancing H is 2. Okay, NH4, H is 4 and H is 2. So total is 8. The previous equation, did you get any balancing, children? Yes, we got that. Balancing is also necessary because why? 2 to find 4. Okay. Here what happens? NH4, N is 1. Okay, N is 1. Cleared. H is 4 and H is 2 over here. So 4 plus 2, it is 6. I'll write 3 over there, and plus what is that given? H3, no? NH3. Okay. Okay, to balance this, I'll write 2H2O and 2NH3. Okay, the given thing is found now. What is that, children? We found all the A, B, C, D, E, F, and I and J. I and J are COH twice and CaCl2. I'll write it here. Okay, I and J. I is CaOH twice and J is CaCl2. The names are calcium hydroxide and the other one is CaCl2. What is name CaCl2, children? CaCl2 nothing but calcium chloride. So these are the given names A, B, C, D, E, F, namely G, H, I, J in the particular previous bit. Okay, this is all about the particular question. Okay, the flow chart with the given hints. You have to find out all the A, B, C, D, F, G, I, and J. Okay, so like this we solved previous questions also, previous worksheets. We found some, we picked some easy and given hints. So now in this particular question we have E is a gas which puts off burning splinter with pop sound. Like that we have some carbon dioxide gas and we have some different things. Okay, those are some hints given. Blue colored copper sulfate solutions and all. So here we have dichromate and green colored compounds, and we have white dense fumes and which turns milky on passing carbon dioxide gas. All these things we have to find out if we do on practicing, and if you know this, note it where. Okay, note the points and it will help you in the future particular bits. Okay, this is all about all the 7 bits from the worksheet 4A mains model. Okay, hope you really enjoyed and solved, and if any doubt, just go other again watching the video again. Where you feel doubt, remember, and you just go with the particular observations and calculations of your own. If you know the concept, you can definitely do the particular bits. Okay, so where you find difficulty, try solving them again and again, and remember that. Okay, it helps you in the mains examinations. Okay, children, here in session. Thank you.